In today's lesson, we're going to answer questions where we know a probability and we need to work out the mean and the standard deviation for a normally distributed variable. And we're going to do this using the standard normal distribution that we looked at last lesson. So let's just dive right into a few examples. In the first example, we've got a normal distribution with a mean which is unknown, which we're going to call mu, and a standard deviation of 3. And we're told the probability that x is greater than 20 is 0.2. Now we can't use the inverse normal function on our calculator because that requires us to know the mean and the standard deviation. But we can use a standardised normal distribution because we will know then that our mean is 1 and our standard deviation is 0. So if the probability x is greater than 20 is 0.2, we can use what we learnt last lesson, that z is x minus mu over sigma, to say that in this case the probability that z is greater than 20 minus mu over the standard deviation of 3 is 0.2. And then this value of 0.2 is one that's in our percentage points table. We could use the inverse normal function on our calculator, but it's easier just to look it up in here and see that when the probability is 0.2, then the probability that z is greater than a value is 0.8416. So probability z is greater than 0.8416 is 0.2. So that value of 20 minus mu over 3 must be 0.8416 from our table. And then it's just a case of solving this equation. So multiplying by 3 and then doing 20 take away our value. So that gives me a value for our mean of 17.48 to 4 significant figures. We shouldn't work to any more than 4 significant figures, or because we've only got 4 significant figures within our percentage points table. Okay, example 2. In this case, we're told the mean and we need to find the standard deviation. And we're told that the probability that x is less than 46 is 0.2119. So let's standardise this. So that tells me the probability that z is less than 46 minus mu, which is 50, over sigma is 0.2119. So 21.19% or 0.2119 is not a value that's in my percentage points table. So this is where we're going to use our calculator using the distribution option, which is number 7 in our main menu, and then the inverse normal, so option 3. So we need our probability or our area under our curve to be 0.2119, and it will automatically fill in a standard normal if we haven't altered it. So that gives us this value here as minus 0.7998. So that 46 minus 50 over sigma is minus 0.7998. And again, this is just an equation for us to solve. So I have minus 4 over sigma, so let's just times by sigma. And so sigma is minus 4 over minus 0.7998. And we can do this using the answer function. So it's minus 4 divided by the answer. So we get 5.0009 or 5.001 to 4 significant figures. In part B, we want to find the 90th percentile of the width. So that means we're looking for the probability that x is less than that percentile, let's call that number A, is 90%, or 0.9. And we now know our mean and our standard deviation, so we can just work that out using our inverse normal function. So our area is 0.9 and we're going to use 50 and our previous answer, and that gives us a value of 56.41. We need to make sure that that makes some sort of sense. So remember, in this case our mean is 50, so our 90th percentile we need to be expecting to be a good way above 50, so 56.41 sounds good. Okay, example 3 then. Example 3 gets a little bit trickier because we don't know the mean or the standard deviation. But we do know two probabilities. So we've got two unknowns, but we've got two pieces of information. So we're going to form two equations and solve them simultaneously. So for the first fact, probability that x is greater than 35 is 0.025. That would mean the probability of my standard normal variable needs to be greater than 35 minus mu over sigma, and that probability needs to be 0.025. So that's one from my percentage points table. So that tells me that that value, that z is greater than, is going to be 1.96. And I'm just going to rearrange that equation by multiplying through by sigma to make it a bit more linear. Right, the second fact we have, the probability that x is less than 15 is 0.1469. So let's standardise that. So that's the probability that z is less than 15 minus mu over sigma is 0.1469. That's not a probability from my percentage points table, so I'm going to use my calculator with an area of 0.1469 and the standard normal function, and that's going to give me a value for that number 15 minus mu over sigma of minus 1.0498. And again, if I multiply through by sigma, that's going to make the equation look a bit nicer. So now I've got simultaneous equations and I've got minus 1 mu in each, so I can subtract the equations from each other. And that gives me 20 is 3.0098 sigma. So dividing by this 3.0098 gives me sigma is 6.645. And then I just need to find mu, so let's substitute into the first equation. So 35 minus mu is 1.9600 times 6.645, which is 13.02. So I just need to do 35, take away that value to find my mu. Or I suppose at this stage we could have used our calculator, couldn't we? We could have rearranged it by adding mu to both sides and then put it straight into our calculator. Going back to old-fashioned techniques here, doing it by hand. Right, question 4, we've got a more worded question. Soup is sold in tins, which are filled by a machine. The actual weight of soup delivered to a tin by the filling machine is always normally distributed about the mean weight with a standard deviation of 8 grams. So let's write that down. So we've got a distribution with an unknown mean and a standard deviation of 8. Proposed legislation requires that not more than 2.5% of tins may contain less than 800 grams. So we want the probability that X is less than 800 grams to be, well, our cut-off point would be where the probability is 2.5%. So the cut-off point is here, so that's the point where we're going to find our minimum mean that would allow us to be within those guidelines for the legislation. Now, we can use our percentage points table, but remember our percentage points table is for where Z is greater than a value, so we're going to need to consider that. Let's standardise it first. So we're looking for a value where Z is less than 800 minus mu over sigma, has a probability of 0.025. If we look at the standard normal distribution, remember your mean will be 0. If we're wanting the probability of being less than that value to be 0.025, that's going to be a negative value for the standard normal distribution. So we're going to be looking at the negative of this value here. So if this value is 800 minus mu over sigma, this value here is minus 800 plus mu over sigma. So this is the same as the probability of Z being greater than minus 800 plus mu over sigma being 0.025. And that value, which has that probability of 0.025, is 1.96. So this minus 800 plus mu over sigma is 1.9600. And we did know sigma in this question, so we can fill it in all the way through our working as being 8. So I just need to multiply by 8. And my mean turns out to be 815.68. So we know for our soup tins, our mean will need to be 815.68, so that only 2.5% of them, so this will be 815.68, so only 2.5% of them are below 800 grams. So it makes sense to have a number bigger than 800, so that we only have a small percentage below 800.